This is Unit 5, Polygons in Motion. Preview video 6.6, Rigid Transformations. Sit tall. Ready? Inhale. Deep breath, hold. And birthday candle. Inhale, hold, exhale. Transformations is motion on a coordinate plane. Motion on a coordinate plane. This is the very basic introduction to things like computer graphic effects. Is how do you mathematically program motion when you can't physically move things around? So we're going to talk about motion on a coordinate plane, and there's 4 types of basic geometric motions, and they're in 2 categories. Rigid, which means you keep the exact same shape, you just move it around. And then non-rigid, where it actually changes the shape. Your rigid geometric motions, also called transformations, so the rigid transformations are translation, where you just slide, reflection, like a mirror, and then rotation, where you pivot and rotate. Reflection, translation, and rotation are called rigid transformations because they keep the same shape, they just move it around. Dilation means to change in size, larger or smaller, enlarge or shrink, reduce. So a dilation is the only one in which the shape itself actually changes. And dilation is where we get similar shapes. Same shape, different size. Taking a look here, translation. To slide, add to the left, add to the right. To slide, add to the left, add to the right. To slide, add to the left, add to the right. To slide, add to the left, add to the right. So to translate a point, let's say you have a point XY, and you translate it by a horizontal component A and a vertical component B. All you do is you add the horizontal component to X, and you add the vertical component to Y. When we say add, it could be add or subtract, because technically you can add a negative number. To slide, add to the left, add to the right. So right here, we have A is at 4, 3, and B is at 7, -1, and C looks like it's at 2 and -2. So we're going to write down the coordinates of this triangle. And our instruction says we want to translate by 6 units to the left. Now left is going to, left and down will be both negative numbers. So left, 6 units to the left will be negative. 2 units down will also be negative. So 6 units to the left, meaning to all the x coordinates, I simply minus 6. 2 units down, I simply minus 2. Let's get our new coordinates. 4 minus 6, -2. 3 minus 2, -1. And that's called A with the tick mark is called prime. 7 minus 6 is +1. -1 minus 2 is -3. 2 minus 6 is -4. -2 minus 2 is 0. Now we graph those. That's A prime. +1, -3. That's going to be B prime, and then negative. Excuse me, that's -4, -4. And that's going to be C prime. This is +1, not -1. There it is. All right, so we have the same triangle. It should be the exact same shape, just slide over. That's called translation. Now, you can, if it's a physical piece of paper, you can bunny hop this. Watch. 6 to the left, 1, 2, 3, 4, 5, 6. 2 down, 1, 2, ta-da, there it is. 6 to the left, 1, 2, 3, 4, 6, 2 down, etc. Boom, boom. And this one, 1, 2, 3, 4, 5, 6, 2 down. There it is. So why don't we just bunny hop it all the time? Because in the computer programming world, you can't physically move around pixels. You have to mathematically program it. So you need to understand the mathematical principle of to slide, add to the left, add to the right. That's translation. This one, you're going to pause the video and do it yourself. Pause. Check your work. There's B, N, and X, and then you translate it, and the translation was 4 units to the left, 1, 2, 3, 4, 5 units up, 1, 2, 3, 4, 5. You did that all 3 points, and you should have gotten these coordinates. -2, 5, 1, 2, and -2, +2. 2, slide, add to the left, add to the right. Now, reflection. Reflection means to flip over and get an opposing image, like a mirror. And there's 2 reflections that we're going to do, reflecting over the x-axis and reflecting over the y-axis. So first we're going to reflect over the y. So just darken the y-axis here. And then kind of draw yourself a little arrow. We're going to take this image and we're going to flip it over this way like a mirror. Seems simple enough. Yes, you can bunny hop everything, but you need to know the mathematical property. Once again, in computer programming, you can't physically move stuff. You have to program it. So to flip over the y-axis, this is what I like you to do. Make a y-axis with your hand, okay, and make a fist. Make a fist, and to flip over the y, motion your hand. We're flipping over the y. Notice the motion of your fist is horizontal. Flipping over the y-axis, the motion of your fist is a horizontal motion. So to flip over the y, you simply opposite the x. So if I have this coordinate, x, y, to flip over the y, you opposite the x coordinate because you're flipping over a horizontal motion. So to flip over the y, you opposite the x coordinate. So this simply becomes -4, 3, -7, -1, and -2, -2. If your number is negative to begin with, of course, it then simply becomes positive. So let's graph. A prime, B prime, C prime. If you've done this correctly, you can see that if you take the image and you simply, if you could physically fold this piece of paper over the y-axis, we call that hot dog vertically, it matches. Just to flip over the y, you opposite the x coordinate. You do this. Pause, do your own work. Check your work. Here you should see that you have flipped the image over the y-axis. It's a horizontal motion over the y-axis. Now to flip over the x, you opposite the y. Put your hand on the x-axis, put your fist here. Now flip over the x-axis. Notice You're flipping over the X, but the motion of your hand is vertical. So to flip over the X, you opposite the Y. Always darken the axis that you're flipping over. So to flip over the X, you opposite the Y. So I take that Y coordinate, you just do the opposite. And now you just coordinate, plot. It should be very easy to see this. Flipping over the y-axis, -8, +8, there's your A prime. -2, +6. There's your B prime, C, -6, +2. There is your C prime, and done correctly, the image is folded now horizontally. Folded horizontally. It matches horizontally if you flip over the x-axis. This page, do on your own. Take a look here, and again, you have flipped over the x-axis by opposite the y. So there's one more, is rotation. And we're going to rotate 90 degrees clockwise, counterclockwise, and we're going to rotate 180. Rotations are the trickiest. So to rotate 90 clockwise, you switch and flip to the right. Put your hands like this. To rotate 90, and go like this with your fingers, go clockwise, clockwise. You switch and flip to the right. One more time, this will help you memorize it. To rotate 90 clockwise, you switch and flip to the right. Let me show you what I mean. So we start with the coordinates x, y. And when we're rotating about the origin. There's other types of rotations where you rotate around a distinct other point. That's not what we're doing right now. We have to start with the basics. So all of these are rotations about the origin. So to rotate 90 clockwise, there's your XY. Clockwise, you switch and flip the sign on the right. To rotate 90 clockwise, you switch and flip the sign on the right. Same coordinates. It's always a good idea to just kind of sketch which direction we're going. And we are going 90 degrees clockwise, which is this direction. So I'm just going to do a quick sketch that this image is going this way. So I recommend you do this in 2 distinct steps. Step 1 is you simply switch the sign, switch the order. Okay, so notice all I did was switch the orders for all 3. Now, you draw a clockwise arrow and flip that sign only. Clockwise arrow, flip that sign only. Clockwise arrow, flip that sign only. Now we're going to graph. So I'm at 3, -4, and that's now my A prime. 1, -7, it's going to go off a bit, that's fine. That's B prime. -2, -2, and that is our C prime. You connect. Now, it's difficult to kind of see, did this work? Here's how you check it. You take any 2 points, set of points. So we're going to choose our A points. And from the origin, we're going to draw a line to A, and then from the origin to A prime. Now, you look at this angle. If you look carefully, you can see, yes, that was 90 degrees, and the direction we went was clockwise. So, yes, we did it correctly. You are going to do this one on your own. Pause the video. So taking a look here, here are your new coordinates, and here's how you check them. We're going to choose any 2 of them. I'm going to choose the N and N prime. Taking a look here, origin to N, draw a line. Origin to N prime, draw a line. Yes, that's 90 degrees. And yes, the direction we went was clockwise. Counterclockwise, same idea. To rotate 90 counterclockwise, you switch and flip to the left. To rotate 90 counterclockwise, switch and flip to the left. So you have X, Y, step 1, you switch the order, and then you flip the signs only on the left-hand side. That's for rotating 90 counterclockwise. Same 3 coordinates we've been using the whole time. A is at 4, 3. B is 7, -1. C is 2, -2. Step number 1 is you switch the order. You have 3, 4, 7, -1, and -2, 2. Counterclockwise means I'm going this direction. So I draw a counterclockwise arrow, switch the sign. Counterclockwise arrow, switch the sign. Counterclockwise arrow, switch the sign. Start graphing. It's A prime. B prime. Nope, B's in the wrong place. I forgot to switch. This is -1, comma 7. That becomes +1. That looks better. +1, +7. That's our B prime. And then C is +2, 2, C prime. Once again, how do you test it? Choose any 2 points. I'm going to choose the A point from the origin to A, origin to A prime. Yes, that's 90 degrees. Yes, I have gone counterclockwise. You do this one, same transformation. Restart your work when you're done. Let's check your work. So you should have gotten 0, 2, +3, 2, and +3, 5. Here's your graph. Again, to test it, choose any set of points. And so I'm going to do the X points. So from the origin to X, from the origin to X prime, 90 degrees, counterclockwise. Last one is rotating 180 degrees. And this one is also a reflection. Just watch physically. If I take this A and go 180, draw with me, and B and go 180, and C and go 180. I think you see that 180, as we know, is a straight line. So what we have going on here, rotating 180, is exactly the same motion as reflecting over the origin. Rotating 180 is the exact same motion as reflecting over the origin. So if you reflect over the origin, you simply opposite both coordinates. So if I have an x, y, I simply go -x, -y. To flip over the origin or rotate 180, same thing, you simply opposite both. It's easy to see this. So opposite both, we'll just plot them one by one. It'll be easy to see. -4, -3. That's your A prime. And you can see I have flipped or reflected over the origin and I have rotated 180 degrees. So every single one of these points has flipped over the origin, B to B, B prime, and gone 180 degrees, C to C prime through the origin, or 180. So to flip over the origin, you opposite both. Last one, you do this on your own. If you've done this correctly, you should have -1, 0, -3, 2, -2, comma 4. And in this image, once again, if you flip over the origin and rotating 180 is the exact same image. S to S prime, over the origin, rotate 180. Summarize the basic concepts from today in your own words.